Thanks, Scott. We'll get started here. So today's webinar is looking at road design fundamentals for WisDOT projects. Specifically, we'll be looking at some basic drawing setup and bringing in of existing data. We'll discuss creation of alignments and profiles as well as some basic editing of them. And then we'll touch on assemblies and subassemblies, and then the meat of the webinar is on corridors and, of course, the surfaces that come from those. So this webinar is designed to be somewhat of a preview of our seminar in Madison next week and our two workshops that follow, first in Milwaukee on Wednesday and Green Bay on Thursday. So we will touch on some things here and there. We'll cover some basics for those of you who really haven't gotten into Civil 3D much, and we'll try to give some more advanced tips and tricks here and there for those who have spent more time in the software. So, like I said, it's kind of a preview, so those other events next week will be more in depth than we will be covering here. So, thanks for joining us. Let me just walk through a few more slides here. Specifically, the drawing setup and bringing in of existing data. What we're going to use is basic AutoCAD X referencing to bring in existing features. And then we're going to use data shortcuts. For those of you who don't know what data shortcuts are, they're basically like an external reference for a Civil 3D object. So bringing in just a surface or just an alignment from a source drawing, opposed to bringing in that entire drawing. And then project setup or drawing setup, it's saving to the WisDOT project folder within that design folder. So we'll be working right within one of those project folders. Like I said, we'll get into alignments and profiles, and we'll discuss some basics on styles and labels. And we'll do some offset alignment creation as well. And what would alignment be without a profile? We'll work with profiles a little bit. We'll make some profile views, which is the grid itself. That's what allows us to view our profiles. And we'll create some surface profiles from our existing TIM data, as well as layout profiles or proposed profiles. And we'll discuss and touch on some styles and labels as well. Assemblies and subassemblies. We will use a few subassemblies off of the WisDOT tool palettes. So that's something we discussed a bit in our previous webinars and workshops, setting that up and getting those installed in Civil 3D. We'll talk about insertion points or marker points on these subassemblies, so some basic subassembly behavior. We'll look at input and touch on output parameters. So input parameters are things like width of a lane or slope of a gutter and a curb. We'll look at some editing commands like moving and copying of subassemblies. And time permitting, we'll touch on assembly offsets, which can be used in a number of cases. One example is perhaps a divided roadway with two separate alignments and profiles. Simple screenshot below of a sample like that. And then we'll go ahead and build some corridors. We're not going to have time to build something like we have on the right there. That's just kind of a sample of what you can do with corridors. These are 3D modeling tools that are built on alignments, profiles, and corridors, or excuse me, and assemblies. But what we're going to discuss is some basic use of baselines and regions. We'll also discuss targeting and frequency. Those of you who have used corridors know that all the power is in targeting. That's where all the magic comes from. And we'll discuss using links and feature lines specifically to be creating a corridor surface. And we will also incorporate a corridor boundary to manage that corridor surface. So let's jump into Civil 3D here. Go ahead and launch this. So I'm opening Civil 3D 2012. That's the current supported version of WisDOT, and we have this configured according to WisDOT standards. So go ahead and launch this, and we're going to start with some basic project setup here. So first is creating a project folder, and just a thing to note for users on the webinar here that are fairly new to Civil 3D, perhaps you haven't done much. I'm going to move through this stuff fairly quickly, so it's designed to be kind of a show and tell, not a training that you could necessarily click and pick and follow along with. And apparently my performance is slow too. So anyway, let's move along here. We start with going to the prospector and the data shortcuts, and we set our working folder. So this is going to be where our project is created. I'm going to set that. Next thing we have to do is create a data shortcuts project folder. This is creating our actual project folder. So WisDOT has a project number being the name of the project folder, so we'll just give it a hypothetical project number. And we'll go ahead and use this WisDOT project template that defines all of our folders. Go ahead and hit OK. Now we have a project set up in that location, in that WisDOT folder or working folder location. I'm going to go ahead and create a new drawing, and this is going to come from the WisDOT template. Okay. I will save this drawing and put it in that project folder. So there's that project 56567878. Go into the design folder, and we'll save this in our pavement corridors folder. And for simplicity, we'll just call this drawing corridor. Okay, now before I can start working, I need to bring in some existing data. We'll start with an X reference, okay, external referencing basic AutoCAD command, and we will attach a DWG. I'm going to go ahead and grab these base files that I have to start with here, copy these, and put these in that project folder. So base data is where we put this stuff. We'll go right inside survey here, and we'll drop these files. Okay, now they're in our project folder. And I'm going to bring in the existing base, which is just some basic geometry. We will let it come in at 0, 0 location with an overlay, and OK, and bring that drawing into this drawing. Okay, I'm also going to go ahead and open up that existing base, or the existing surface drawing. And of course, what we have to create is a data shortcut from that existing surface. So I have a surface in my source drawing here. Okay, sometimes it may be the existing base and existing surface that are the same drawing. But I'm going to go ahead and associate this project to the current drawing, so that project there. I'm going to save the drawing. You always have to save it before you create a shortcut. And then I'm going to create the data shortcut. So unlike XREFs, you have to first go to the source drawing, create the data shortcut, and then you can go to the destination drawing and bring that surface in. So I'm all done in the existing surface drawing. And close out of here. Now I'm back in my corridor drawing, and I can simply browse to data shortcuts, and here is the data shortcut to that EG surface. I can create a reference, and it comes into this drawing on the correct layer with the source drawing's name, and I can assign a different style here. I'll go ahead and give it one called existing contours, 5-foot major, 1-foot minor. Hit OK, and now that surface data is in here. I, of course, cannot edit this surface. I have no editing options up here. I have only labeling and analysis options. Okay, I've got my corridor drawing. Let's start by making an alignment here. So I'm just going to rough something in here. I'm going to draw an alignment in and work with it a little bit, and we're going to move right on to profiles. So alignments in Civil 3D, like most everything in Civil 3D, you can launch from the Home tab up here. So we'll go right up here to Alignment Creation Tools. Now I'm going to create an alignment, and we'll call it, for example, 13th Avenue. So this first example here is more of an urban street where we're going to use curb and gutter as a sample here. And I've got a alignment style. We'll leave it at proposed, and then a label set. We'll put at 1 inch and 50-foot text. Okay, so all these styles we're using here, these are all the WisDOT styles. We're going to start by freehanding one in here. I'm going to go to tangent with curves, and we're just going to pick a point here. We're making this up. Mid between 2 points, we're going to go right to the center of the road here, start the alignment right there. We'll start by just making a basic alignment like that. Okay. It's one of the unique things about alignments in Civil 3D. They behave kind of like a polyline in that you can grip on them and move them Let the labels move right with it, so pretty nice behavior, huge time saver. Things like the radius of a curve, for example. We can come up here to our profile or our alignment grid view, and within Panorama, I open that again. Within Panorama, I can change the radius, for example. Okay, if you had polyliner geometry in place, perhaps an existing alignment that you have geometry for already, you can of course create an alignment from objects, which would be from a polyline. I'll go ahead and dismiss that grid view. So alignments are pretty easy, pretty nice to work with in Civil 3D. Let's move right on to creating a profile. We'll start by picking on the alignment and going up here to Surface Profile. And in this drawing we have an existing surface. I'll go ahead and add that into the list down below here. I've taken the defaults here, which is to sample the full station length. And of course I only have the one alignment in the drawing, so we're sticking with 13th Ave. I'm going to go ahead and hit Draw and Profile View. And it launches me into another wizard, the Create Profile View wizard. I have a Profile View style. Okay, so for those of you who aren't familiar with this, the profile itself, meaning the line we'll see, is a separate object from the profile view, which is the grid. That's why there's two separate windows here. So Profile View style, we'll start with 100-foot major. We'll just take the default there. We're going to hit Next and take an automatic station range, which is just based on the alignment itself. Hit Next again. Profile View height, that's going to be based on the existing surface elevations. Hit Next. Here's kind of a summary of what we've got set, what we're going to be sampling. It's usually just one setting you're concerned with here, potentially two, one being the style. Okay, and right now we have that set to proposed. This is actually an existing surface profile, so I'm going to set it to Profile Existing. And then the labels, that's defaulting to standard. We will set that to Profile Description. Excuse me, not Profile Description. No labels. No labels on our existing surface profile. We'll hit Next. The band set, this will be labels along the bottom of the profile view. And right now they're both defaulting to our existing surface profile, and that's because that's the only one we have in the drawing right now. So I'll hit Next. Profile hatch options, not a good idea, really bogs down the drawing. And we'll drop this off here to the right. Got existing surface profile there. So again, as I mentioned, the profile view is one object. It's the grid that you see here. The profile itself is another object. It's the cyan dashed line here. So separate styles, separate layers, separate behavior. What we're going to do from here is we're going to draw on a design profile. So I'm going to pick on the Profile Grid view and go to Profile Creation Tools. It's going to name my profile based on the alignment that it's coming from. I've got a profile style, a profile proposed, and a label set. We'll grab standard profile description. So this is my layout of my proposed profile. I definitely want to see labels on there, PVI labels, and that sort of thing. So I'll hit OK. I'm going to close my alignment layout tools here. Now I'm working with my profile layout tools. There's quite a myriad of ways we can edit this profile. I'm going to start on the left here, and I'm going to draw tangents with curves. So what this is going to do is everywhere I click, it's going to put a PVI and then insert a vertical curve of a default length of 200. We can drop that down perhaps to 100. I'm going to select Draw Tangents with Curves now. And for a starting point, I'm just going to go right to the start of the alignment, or the zero station point right there. I'm going to turn off my all snaps and we'll pick some preliminary locations here. And we'll snap to the end right here. Okay. So I just kind of roughed that in, right? Okay. In Profile Layout Tools, we also have a Profile Grid View. So I can come in here after the fact and keeps wanting to disappear on me. There it is. And I can tweak some of the station of these PVIs. So you notice as I pick on it, it shows up as a little triangle in the grid there. Different PVIs, really handy. So I can put this at a nice round number, for example. I can change the state or the elevation value, 834 to 0.3, we'll say. Okay, and labels automatically update with it. Alignments and profiles in Civil 3D. If you haven't used them yet, they're very nice to work with, very easy to work with. There's a myriad of other tools in here. For example, we can delete a PVI. I can delete this out of here. That disappears. The labels update right with it. Okay, I can insert a PVI right back in here. Maybe it's a PVI without a vertical curve. Maybe it has a vertical curve. If you have the PVI in place, we have, among a bunch of other options, we have a free vertical parabola, PVI-based one. So if you have the PVI in there, I can pick near it. It prompts me for a vertical curve length. I could say perhaps 50, and it throws in that vertical curve. Okay, so a lot of flexibility, a lot of options there. A few other things like raising the entire profile, all the PVIs at once, up a half a foot to foot, whatever the case may be, and a lot of other options here. Okay, where we want to start this profile, we're going to have the proposed profile start right at the edge here. Some people do this differently. You might start it here and have the gray just match existing. Either case, we have to get a station and an elevation right there based on existing surface and the location of this curve line, that flange of the curve there. So there's a nice little tool called the inquiry tool. If I pick on my alignment, I come up here to inquiry. I can do an alignment station, offset, and surface elevation at point inquiry. So this is kind of a quick, easy tool to get the station and elevation at that location. So I can pick this little green box here, zoom in here, and we'll do an apparent intersect. We'll grab that location. Notice I have surface name set to EG. It's giving my station and my elevations there. So a nice little tool because I can now just come over to my profile, click on that guy, go to Edit Profile Geometry, open up that grid view again, and I can set that starting station to what I found in the inquiry. So starting station, 29.17. Starting elevation, 833.546. Okay. About 10 other ways you can do that. I find that to be the fastest, the easiest, and the most foolproof way because you get this little window that comes up, it stays in place. Nice way to work with. That goes for just about every Civil 3D object in there. You pick on it, you get inquiry. I pick on the profile, I get inquiry. Okay, all sorts of information you can quickly garner from your Civil 3D objects. Okay, so that's a quick overview of alignments and profiles. Let's discuss alignments a little more, though. Let's look at making an offset alignment. So I'm going to pick on this alignment. And like most things in Civil 3D, if you don't know where to find the command, you know, there's only about 2 million commands in here. When you're new to Civil 3D, it can be very helpful just to pick on the object and then look up here in the contextual ribbon. Most often what you want to do, you'll find it right there. So we'll pick on offset alignment. And what we're going to do is we're going to make an offset alignment to the right side that represents the edge of pavement. And we're going to put in a widening in there as well to represent a turn lane or perhaps a widening for a parking lane or something to that extent. So I'm going to say number of offsets on the left will be 0. Number of offsets on the right will be 1. And we'll go offset, we'll just say 12 feet. This is going to make a new alignment. And I'm going to put the style to pavement edge. In the label set, we don't need another set of stationing labels, so I'll set that to no labels. I hit OK, and it throws that in there. All right, one of the great things about offset alignments, okay, I could have just done an offset command, 12 feet, for example. Okay, that makes a line over there. But offset alignments stick with the primary alignment. So a really nice way to generate supplementary lines based on your center line alignment. So let's get rid of that polyline. What about alignment widening? Okay, if you pick on that offset alignment, perhaps we have a bump out or a parking lane, or it could be a turn lane. These can be used in many, many different ways. You can pick on the alignment and select Add Widening in the contextual ribbon. And then it prompts me in the command line, create widening as a portion, widening portion as a new alignment. I'm going to say no. Then it says pick start station. So I could snap to that location right there. Let's say station 9. And end station, I could snap, or I could also type in 1200, for example. Then it's prompting me in the command line again, enter widening offset. This is from centerline. This is not in addition to the offset alignment. So I'm going to say 24, and it now bumps that out another 12 feet. This thing's real dynamic so that I can grab those transition points there, these grips, and move that transition. So if I can pick on this gray grip here and change the actual start and end stations of these transitions. Over here I've got my offset alignment parameters. It's defaulting to a linear transition type, but we have curve, line, curve, all sorts of options in here. Linear is what it's defaulting to. It should be what you can use in most cases. All right, let's go and dismiss that. That is offset alignments. And again, that whole widening moves with the offset alignment as well. So pretty cool tool. All right, let's discuss the third component to corridors, which is assemblies. We've got alignment, we've got a profile, so we've got a 3D path for our roadway. Now we just need an assembly, and what assemblies are your typical sections or your templates, like they used to be called in Land Desktop and a few other programs. So we're going to start by coming up here to create assembly, and we'll call this assembly 13th Ave. Hit OK, and we'll insert this right up here. Automatically zooms right in there. So assemblies are not that exciting. It's these subassemblies. That's where all the power is. So it inserts this little marker up here. In fact, I'm going to drop my drawing scale down to 1 inch to 10 feet. And it will make this marker a little bit smaller. So now, subassemblies, where do you find those? You find those on the tool palettes. Okay, I've got mine open right here. It's also this button right up here to turn your tool palettes off and on. And I already have my WisDOT subassemblies loaded, so I can go right to that tool palette group. And I've got mine organized in 6 different tabs here with a number of different subassemblies on each. You can organize yours any way you want. I'm going to start with this one on the lanes tab here, and we're going to look at lane generic. So I'll pick on that, and I will connect that to the assembly connection point. All right, some fundamentals of subassemblies. The assembly is just a marker point. That point right there is where the alignment and profile are. So this assembly will ride along that. And then I attach the actual geometry representing lanes and curves and ditches and so forth. This subassembly here, this is a lane one. If I go ahead and open up properties, you'll see I've got a lot of options here. And if I minimize all those categories at the top, just looking at advanced, these are all the parameters I can set. Okay, so the width of the lane is perhaps 12 feet, the slope perhaps something different. The way these are defined, some of these are a little different than the out-of-the-box Civil 3D subassemblies, which some of you may be familiar with. The depths here are all based on finish grade, so pavement 1 depth, perhaps it's a ½ foot. Then the base depth, if I set that to 1 foot, that's coming from finish grade. So if I want a ½ foot base depth, I'd set this to 1. If I wanted a 1 foot base depth, I would set that to 1.5. So when you enter in numbers like I just did, 15, it kind of bugs out and tells you that that's not going to work. So we're going to do a sub-base depth of 2 perhaps. And then a depth to subgrade, I'm just going to zero that out. There we are. Base depth could be 1. There we are. So what we end up with is half a foot of pavement, half a foot of base, and a foot of granular, or whatever the sub-base material is. So that's a lane. I can go back to my tool palettes. I can go to the Barriers and Curb tab, and I can grab the CG Gen Curb subassembly. And where I attach these now, you might have noticed before I picked on the assembly. If I want this curb to attach out here, I now need to pick on the finish grade marker point of that lane. So the marker point are all these little circles and the white bullseyes, and the insertion point is, if you pick on the subassembly, you'll notice there's a grip. That's the insertion point. So when you're dragging those off with the tool pallets, your cursor is right where that grip is. It's pretty much always the inside finish grade marker on the subassembly. So here is the curb subassembly. I can, of course, on this go here, and they've got a lot of nice options here. WisDOT has built a pretty decent curb subassembly. We can change through different curb styles here, and you'll see how the geometry changes. Curb height, curb size, very handy. Okay, and in this as well, we can put in a base depth of 1 foot and perhaps a depth to subgrade of 2 feet, and match our materials on our lane. Okay, from here I'm going to do a basic daylight subassembly. So I'm going to leave that small little terrace or boulevard there. I'm going to go to the daylight tab and grab this basic generic cut fill subassembly. I attach it to the outside finish grade point, and what this thing will do is it will put in whether I'm in cut or fill at this point, it will do different behavior. It will either fill to existing ground or cut to existing ground. Okay, a couple subassembly editing tools. If I want to take all these and I want to match it on the other side, I can window around all those. I can select mirror. I can mirror about the assembly point right here. No reason to recreate all that stuff. So it's a nice workflow. Define it how you want on the right side, then mirror it to the other side. And there is our basic road assembly, typical section, however you want to think about it. Think about it as assembly. That's what Civil 3D calls them. You'll have an easier time if you get on board with the Civil 3D terminology. All right, we've got an alignment, a profile, an assembly. Now we can make a corridor. Corridor is an object that creates your roadway. It's a 3D representation of your roadway, and it takes those 3 components before you can actually create it. It won't even let you create it beforehand. So I'm going to come up here to corridor and create corridor. It's going to prompt me in the command line, select a baseline alignment. Okay, I hit enter and I can pick it from a list. Instead, I'm going to grab 13th Avenue. Hit OK. It's prompting me for a profile. I can hit enter again and grab the profile that corresponds with that alignment. First one there is the EG one. The second one is that design profile we created. So I'll hit OK to that. Third thing, it wants an assembly. These corridors are very needy. We've got one assembly we created. We call it 13th Ave. We'll go ahead and pick that one. I'll hit OK, and I get the Create Corridor dialog box. I can shrink this down a little bit here. Got a name of the corridor at the top. We could call this something different, like 13th Ave. Okay, some fundamentals to corridor building. They're made up of baselines and regions. What a baseline is a 3D path defined by an alignment and a profile. But without a region, the corridor has no shape to it, because you have to take an assembly, and extrude it basically along a station range. So here's the region. Here's my assembly assigned, 13th Avenue, and here's the station range. Okay, I can change this. I can come out here and pick a different one, or perhaps type something in, or snap to a saw cut line where we're matching in. And I can change it on the back end as well. I'm going to hit OK, and we'll create that corridor and see what we're looking at. So this is a corridor object. It's the bread and butter of road design and Civil 3D. Let's go ahead and take a look at this corridor and section editor right away. Those of you who haven't used section editor, a very nice tool to be looking at your corridor in both section view and plan view. There's a little bit of configuration here. If we go up here to viewport configuration, we can set it up so we have 3 different viewports. And we're going to go to 3 above. In the top one, we're going to put our section view. In the bottom left, we're going to put plan. In the bottom right, we're going to put profile. As soon as I hit OK, it's going to prompt me, do you want to save this? Every time you go into section editor, I'm going to say yes. And then it reconfigures my screen. Okay. Now if you look up here, the ribbon has changed. We're in the section editor mode. Okay. And looking at a certain station. Right now it's at station 0. That doesn't really make sense because I don't have any corridor over there. But I can pick this white slider down here, bring it down to the middle of my road, and there is the section of the road. So a very handy tool, section editor. Used to be a little bit buggy a few years ago. They really improved it in 2012, and in 2014 it's even better. WisDOT is looking at doing that in the coming few months, moving to 2014. So here's our corridor and section view. One thing you'll notice is it's not daylighting yet, right there. We have to assign something called targets. What targets are objects that you assign to subassemblies in our assembly to make them behave in a certain way. So right here, these are the daylight subassemblies. I need to have my grading match into existing ground. Existing ground is this line right here. In fact, we'll make a quick surface style change, get that looking the way it should. Give it a yellow color, just so it stands out here. Gotta let WisDOT know. Change those styles a little bit. So we need to match in there. So I'm going to come to my corridor, I'm going to pick on it. I'm going to go to Edit Targets up here. So targets, what are targets? Targets are where all the magic is in Civil 3D. I pick on Edit Targets and it prompts me to select a region. Well, if I hover over my corridor, it's my entire corridor. It's because I only have one region. Go and pick there. There's 3 types of targets. Right now we're just discussing the first one, which is surface targets. And what I need to do is assign existing ground surface as a target object for those daylight subassemblies. And what it will of course do once I hit OK is it will make this thing behave the way it should. So it's cutting those ditches in there and so forth. That's probably not the ideal subassembly for this tool, but you get the idea here. So there's other tools in there that where we just daylight at a 2% and a perhaps a typical recon. We happen to have thrown the ditch one in there. So, but you get the idea. So section editor, very nice place to be. I spend a lot of time in here. When it comes to assigning other targets, for example, we've got that offset alignment. Okay. Let's say we want that to represent the lane width on the right side of our roadway. Okay. Over here on my subassembly, I've got just a default width. It's set to 15 feet. But it's going to vary, and this is going to be the case in most any project. That's going to vary. You've got medians in the middle, you've got turn lanes, parking lanes, you name it. It's going to vary. So we need to assign a target to this subassembly. So let's pick on our corridor again and go to Edit Targets. Hover over the corridor. We'll come right into here where we can assign targets. Okay, the first one we did was a surface target. The second type is width or offset targets. These control the width parameters or the offset parameters in a subassembly. And what we're looking at doing is controlling the width of the lane subassembly. So this one right down here. And what you've noticed probably is that it says lane generic right, and what do we have down here? Lane generic right. Okay. They've actually improved this some in 2013 and 14. There's some automatic naming that improves it. But until then, we've got to take this into our own hands a little bit. So let's close out of target editing. Come over here to our assembly and go to Assembly Properties. If I look on the Construction tab, there's that assembly name. And what it does is it just says Group 1. Well, Group 1 was the first group we made, which is on the right side. So instead, let's call it right. And on the left side, call it left. And just to really avoid confusion, we'll pull out that text there. Now in Civil 3D 2012, you have to have unique names for every subassembly, so we'll just leave some of those numbers after it. But they have changed that in 2013 and 2014. You can have the same name, so it makes some of this stuff a little bit nicer. So I'll hit OK. Now if I come back, pick on my target, go to Edit Targets, hover over my corridor and pick that. Now in the target mapping window, I can see I have my lane subassembly right side, lane subassembly left side. You'll also notice that the curb subassembly is in here many different times. Okay, you can assign all sorts of targets to control. I'm sorry, that's the cut fill subassembly. You can assign all sorts of targets to control where those ditches lie, tops of slopes, bottoms of slopes, and so forth. It's a little bit more of an advanced topic. We're not going to quite get into that today. So we're looking at the lane on the right side. Pick here where it says None. Now I have options. I can select an object type to target. I have alignments. I also have feature lines, survey figures, and polylines. We're dealing with an alignment, and we're dealing with the 13th Ave right 12-foot offset alignment. So I can highlight that, hit Add, and it shows up in the list. Hit OK. I'm back here in my target mapping window that shows up. I can confirm, yes, that's what I wanted. Now when I hit OK, my whole corridor will bump out and make that change. So you'll notice there's my slider. That's what section we're currently looking at. If I scroll through that corridor, you're going to see that lane start to bump out on the right side there. Gets wider, so on and so forth. It's all dynamic, so that if I come in here, I'll send that corridor to the back, so I can now pick on that alignment. Any change to this offset alignment, like that, so that offset alignment's over there. That target stays intact, so that I can pick on my corridor now and simply tell it to rebuild, and all those curb lines, all those daylight lines, everything moves right with it. So very handy, very dynamic, really one of the most powerful tools in Civil 3D. So that's some kind of introductory stuff to corridors. I'm going to jump into another drawing here. We've got a couple alignments and profiles set up. And we'll touch on some more, a little bit more intermediate, more advanced stuff that you guys can be using. One note, when you're done with Section Editor, okay, you always want to close out of it. If you don't close out of it, you get some struggles. Tends to be a little weird. All right, let's go ahead and close this drawing. I will save it. I'm going to open up another drawing that I have set up already. Pretty much similar drawing. And I've got a couple alignments defined here. Okay. I also have a couple profiles. So we're talking more of a divided roadway here. We've got an eastbound and a westbound alignment. This one here, if I pick on it, it's 13th Ave eastbound. This one up here, it's 13th Ave westbound. Let's look at creating a roadway where it has no curbs on the outside, ditches on the outside there, so there's a shoulder as well. On the inside there's a little rollover median. Let's go ahead and define that. So it starts with our assemblies. If I come over here, here's the assembly we pretty much had in the previous drawing. What we're looking at here is an eastbound and a westbound, and many times you have separate alignments and profiles that define that geometry, and then a median in between is kind of acts like a rubber band. Its slope and width just kind of changes depending on what those do. So there's turn lanes that come in and out, all sorts of things. So we're going to set up just a portion of what a corridor and a more divided roadway example would look like. So I'm going to start by picking on my alignment and going to add offset. And then we'll put this just over here. So this is what's called an offset assembly. This assembly is going to ride along the alignment on the north side here. The other assembly is going to ride along this one. And the reason we use an assembly offset is that it will be all in one and it will all be based on one alignment station. So let's make some modifications here. Let's delete that curve out of here. We'll go to our tool palettes, and on the lanes tab, we'll grab a shoulder constant width. Okay, I can attach this to the top outside of the lane there. Now this daylighting subassembly, I can pick on this, and in my right-click menu, or also in the contextual, we're going to have copy to and move to. Okay, these are special subassembly commands that apply only to subassemblies. We used the mirror one before, not to be mistaken with AutoCAD here. What we're looking to not do now is move to. So this is how you want to move your subassemblies. You don't want to pick on them and do simple grip edits like that, though there's a reason and application for that. You want to do the move to command to move them to a different marker point within the assembly. Okay, on the inside here we can grab this lane and let's change this to positive 2%. Then we can grab this curve here. We can change the curve type, for example. Perhaps it's a T-type curve, and we can modify these slopes as well. I'm going to go ahead and delete the daylight subassembly here. Let's also pick on that curb assembly again. Let's bring that terrace width way in here, at 1.5 feet. So 1.5 is from back of curb. So there's 1 and 0.5. Okay, there's that side of the road. On the other side, okay, it's mostly the same, but then with a median in between. So I can actually grab some of these, like this entire set of subassemblies, and I can use the mirror command and mirror it over here. I can also do the same thing here. And this is a little bit weird. I can mirror this thing, like an inverted mirror over here. Okay, now where these two things are located relative to one another, if this offset assembly is sitting up here, if it's sitting down here, it makes no difference because it's the alignments and profiles that we assign to those that will control the location of them. So one other thing to create that median here. Now, WisDOT has provided a number of median subassemblies, some of them a little more advanced than what we're getting into today. So I'm going to introduce a little bit more basic one that still has its application in projects you guys will be doing. And this is, we're going to find this in the Civil Imperial Subassemblies tab, or the group rather. And on the Generic tab, we're going to find the first subassembly we're after. This is called the Mark Point subassembly. So if I go and pick on this, and I attach it right here, you'll see nothing really happens. Well, it inserted one thing, it's a little marker point. So there's no lines or anything associated with it. If I go to Properties, you'll see I have a point name. We're going to call this BC1. Now, if I go to the other side of the road, and I attach a median subassembly there. In fact, I'm going to use this one here, median raised constant slope. And I attach this on the other side. Okay, there's a default depth there. The way this thing works is it's looking for a mark point. A mark point is what we just attached here. This subassembly is looking for a mark point. In fact, it wants a mark point name. So if I put in BC1, it's going to attach to this, not in the assembly view, but once I build it in the corridor, this thing will always connect right there. So it's going to be like a rubber band, as those eastbound and westbound roadways go in and out and up and down relative to one another, that median in the middle is just going to stay connected. There's all sorts of different strategies for managing these material depths and so forth here, but I want to show you just the basic functionality of this median. Okay, next step is to build a corridor and assign some targets, and so forth. So that assembly is named 13th Ave, 13th one, call it 13th divided. Okay, I've got my alignments, my profiles. Let's go to the Home tab and create a corridor. It's prompting me for a baseline. I'm going to hit enter. Okay. This is the baseline of the primary assembly, not the offset assembly. So that's going to be the one on the right, which is the one on the south end here. So that is the eastbound one, 13th eastbound. Wants its profile now, so I'm going to grab that design profile associated with that. And of course, wants an assembly, we will stick with 13th divided. And we've got a corridor name. We can again call it 13th Ave. Again, we have those same options here. We've got a baseline we defined, alignment and profile. And we've got a region we defined with an assembly extruded along the station range. I can again change that station range here. So perhaps this is just a portion of the road. We're just going to model one region here, a portion of the road where there is a median. And then alignments would come back together like this, for example, and the median would end. So we won't have quite time for all that, but we will show you how to model these medians. So this offset here, this is looking for an offset alignment and profile. Excuse me. It's looking for an alignment profile to be assigned to the assembly offset. So this is that other side. This is that westbound side. So we need to give that an alignment, the 13th Ave westbound, and then its associated design profile. Okay. By default, we'll take that same station range. Now if I hit OK, it's going to create our corridor. And to get a better picture here, we're just going to go ahead and look at this in section editor right away. So I'll pick on the corridor, go up here to section editor. Now it remembers those settings from the last time I was in here, which is handy. I can go grab this slider, come right up to middle of the roadway. Okay, a few other things on the contextual ribbon of the baseline of the section editor. I can select the baseline. I've got two baselines. And when you've got a divided roadway like this, sometimes it's a little goofy where the section comes in, but you can get a decent view at it. But if you see down here, there's my red slider. That's where I'm currently viewing, the current station I'm viewing. I can scroll along there, and as I do, you'll see those roads will move up and down relative to one another. I pick this slider and bring it down here, and the median gets narrower. You see it's also narrow in section 2. It's a pretty powerful tool. You'll see how it's connecting. It's just like a rubber band right up here. No matter what those alignments and profiles do, if I rebuild that corridor, that will show up. So of course we have some targets to assign here. I can pick on my corridor, go to Edit Targets, pick on the region, and assign my surface targets. So this matches in. Existing ground, that same subassembly. Now if I go into my Section Editor tab, you'll see it's now cutting those ditches. So as I mentioned before, everything's very dynamic in here. I've changed anything, the alignment, the profile. I bump that out, for example. All I have to do is pick on the corridor, select Rebuild Corridor, and everything will update again. So very handy tool. Corridors are where all the power is. So what else? We can combine some other things in here as well. Perhaps there's a widening, a bump out or something like that, a turn lane. We can add an offset alignment like we had done previously. We'll put it on the right side, and we'll go out 12 feet. There's that offset. And then I could add a widening on that. So go from right there, right there. Okay, so we can see that offset alignment there, that widening bump out right there. Now what do I need to do? I need to assign that offset alignment as a target to this subassembly, right? And now subassembly naming becomes even more important, because if I go into my assembly properties over here, it's that 13th divided, and I go to the construction tab, now I've got a lot more subassemblies in here. So the name becomes quite important. So to make this simple, let's just pick that subassembly. Let's just rename that one. And we'll call this one eastbound lane right. Now if I go in here, click on my corridor, go to Edit Targets, click over this, I will find that eastbound lane right. I can pick right there and assign an alignment target to it. It's going to be the eastbound right 12-foot offset alignment. Add that to the list. It shows up here. Hit OK. And now I've got that bump out. As I scroll through the corridor, again you'll see how that changes. You see on the right side up there, that lane will start to narrow. Okay, very cool tools. All right, a few more things here before we wrap up. Corridor surfaces. Well, corridor surfaces really should be just a byproduct of your corridor. You should spend your time on the corridor, modeling that in the way whatever the design calls for. So corridor surfaces, if you simply pick on the corridor and go to corridor surfaces, you get a window here, you get a surfaces tab, first button here, create a corridor surface. Okay, that's just an empty container. We have to define the surface itself. And what we can define that with are what are called links. So data type called links, and we have all sorts of different levels or layers in our assembly here. So the top one is the finished grade links. That's these orange lines over here. We want to define it with top finished grade links. So we hit plus, and it shows up in the list there. If I go to the boundaries tab now, I've got the name of my surface. If you right click on it, you've got corridor extenses outer boundary. Okay, those of you who have used this before might have given you some trouble here and there. One of the tricks to this, the only way this works in 2012 is, one, if you have more than one baseline. We have two in here. We have eastbound and westbound. And also, the boundary won't work very well if the corridor is overlapping itself in any way or if there's a gap in the corridor. So it's a great tool so long as you have a nice, detailed, accurately made corridor. So we'll hit OK. And it made our surface. Of course, we can't see it. The default surface style was one with just a border. So if I pick on that surface, go to Surface Properties, and change it from border to proposed contours 5-foot major, 1-foot minor, hit OK, and now that surface shows up. So we can see those contours there. Nice crowns like we'd expect. Okay, so some of the detail, perhaps we want a little more detail in this area. It all comes down to corridor frequency. So if I pick on the corridor, I come up here to frequency, select Edit Frequency. I hover over the corridor and pick that. It's modeling every 25 feet. Okay, I could perhaps bump that to 12.5 feet. both along curves and tangents. And now it's going to insert the assembly twice as often. And the surface is made from that exact corridor, so there's going to be a little more detail in there. All right, let's close out of section editor. Let's go back to a full plan view. We'll take a look at this surface, see how it's shaping up for us. I'm going to look at it right here in Object Viewer. Object Viewer is a nice separate window to do a preview of just singular objects. And what we want to do before we view this in here, we want to be able to see our tin lines. So let me escape out of here and make a tweak to this surface style. And make sure that in the view direction of model, which is an object viewer and an ISO view, we have triangles showing. So it won't show up in plan view, but when we go back into object viewer and we look in model view, there's our triangles. Okay, so nice looking curve on the left side here. You can see those contours ramp right down that curve. One thing you'll notice is the tin lines look all screwy on this side. So you can see the lines going perpendicular to the alignment. Those are my links. But then the lines going this way, it's not necessarily following that curve line. So this is a common problem when you have things being modeled not exactly parallel to the baseline. In this case, it's a widening or a taper, or anything just slight like this. So what you can do, if you go back to your corridor surfaces, instead of defining it with just those perpendicular top links, we can also define it by the parallel running feature line. So that's all the lines running this way, like edge of pavement and the curve lines and so forth. And I can add a number of these feature lines in here, like back a curve, or perhaps flow line gutter. So all these key geometry points, I can grab the flange, these key geometry points along my curve. So it's when you've got these sharp grade changes, just general lanes and shoulders, you won't run into this problem. But when you've got curve with steep, sharp grade changes, your surface may not behave exactly the way you want it to. We'll add one more top of curve, so on and so forth. Hit OK. Now if we look at the surface and object viewer one more time, you're going to see a difference in the way it looks along that curve. So now all those tin lines are running right along that stuff. And the tin, that's where all the magic is. That's one of the main deliverables for WisDOT projects. You want your tin looking appropriately. And Civil 3D, while it's pretty powerful, it's not really that smart. It just does what it does. Sometimes you have to understand what it's thinking. So when it comes to your top surfaces, oftentimes you have to add in feature lines like that. So a lot of different strategies to kind of work with that. So anyway, that kind of wraps up what I wanted to show you guys today. Just an introductory to alignments and profiles and corridors and assemblies. We touched on a few basic fundamentals and a few other advanced topics here. Now that that screenshot I showed you in PowerPoint, okay, there's a number of baselines going on in there, a number of all sorts of different targets, but it's strategies we use today along with a number of other things. So it's all this stuff can be modeled and created within Civil 3D. Just a few other things I want to mention, you guys. Didn't look like we saw any questions come in, so I just want to mention a few other things. Hopefully you guys are aware of this stuff. CTC, we are a WisDOT certified training center. We've developed an entire WisDOT consultant training plan. In fact, I can go ahead and open this. We'd be glad to share this with you guys. It's an official document that represents all the training, our philosophy, scheduling, how we run this training, different options for doing it on-site at our office or at your office, and then the different modules or packages associated with it. And all this stuff is in line with WisDOT recommends. Our pricing is fairly competitive. It's $145 an hour for custom company-specific training, or as demand ramps up for this training, we're going to have open enrollment training, and that will be $50 per hour per person. So please reach out to us. We'll be glad to share this document with you. Something that we are currently working with a lot of WisDOT consultants already, and as that date next July 2014 approaches, if they don't bump it back, that is, more and more people will be involved in learning the software. So, of course, there is the WisDOT resources. There's the learning tracks you can find on their website, and a few other things I'd like to mention. Some upcoming events next week. We've got our seminar in Madison. We hope to see all you guys there. It's going to be a great meet and greet. Come meet CTC. Come meet myself. I'd love to meet you guys. Meet some of our other instructors. Come test drive Civil 3D. Come test drive InfraWorks. Or just come for some free breakfast and pastries. Either way, we'd like to see you guys. And then following that on Wednesday, if you can't make it to that seminar, come to Milwaukee. We've got an in-depth workshop. So this will be hands-on training, a half-day workshop where we'll go through some of the stuff we did today, different samples certainly, but some in-depth training on corridors and targeting and that kind of stuff. At least what we can fit in 4 hours. And then, of course, we're going to have the same workshop in Green Bay on Thursday of next week. So we've got a lot of people signing up for those. There's only 12 seats there, so we expect those to fill up. We hope they fill up, but there's only 12 seats, so go ahead and get into that soon and get started on learning Civil 3D and moving your company towards effective use of it. So thanks again for watching. Again, my name is Brian Lewandowski.